Hello viewers, in today's session we are going to discuss another important problem from maxima and minima. So here we have to find out the maximum and minimum value of this function, that is y is equal to 3x raised to 4 plus 8x cube minus 18x square plus 60 raised to 5, right? So here we have a polynomial, and this polynomial is raised to some power, that is 5, and we'll see how we can find out the maximum and minimum value of this function with the help of a second derivative test, right? So let us start. So here let us first assume this polynomial as a function, say z. So we'll take z is equal to 3x raised to 4 plus 8x cube minus 18x square plus 60. Then this function y, it takes the form z raised to 5, right? So here we are going to use the concept that if we have a function, say a y, which is expressed in some power of a function f of x, let us say the power is m, right? And we have to find the maximum and minimum value of this function y. Then what we do, we take this function as z is equal to f of x, so that we have y is equal to z raised to m, where m is a constant and this m is greater than 0, right? So to get the maximum and minimum value of this function y, what we do, we take z is equal to this function, and then we'll find out the maximum and minimum value of this function z, right? And once we get the maximum and minimum value of this function z, we can easily find out the maximum and minimum value of this function y, which is z raised to this power m. So we can say that this function y is maximum or minimum according as this function f of x, which is z, is maximum or minimum. And here I will make use of the second derivative test. So let us first differentiate z with respect to x. So dz over dx is given by 3. The derivative of x raised to 4 is 4x cube. Then here we have 8. Derivative of x cube is 3x square, and here we have minus 18 x square. The derivative is 2x, and here the derivative of 60 is 0. So we have 12x cube plus 24x square minus 36x, right? So this is our first derivative of z with respect to x. So let us find the second derivative here. So the second derivative is given by here we have 12. The derivative of x cube is 3x square. Then we have 24 times 2x minus 36 times 1. The derivative of x is 1. Derivative of x square is 2x. So we have 36 x square plus 48x minus 36, right? Okay, now let us come to the first derivative of z with respect to x. Now see, this function z is a maximum or minimum if we have dz over dx is equal to 0. So for z to be maximum or minimum, the first derivative should vanish. So here we have 12x cube plus 24x square minus 36x is equal to 0. So simplifying it, taking 12x common, we have x square plus 2x minus 3 is equal to 0. So we can now have x. Now this 12, when we divide both sides by 12, we can get rid of this 12, and here by splitting the middle term we have x square plus 3x minus x, and here we have minus 3, that is equal to 0. So we have x plus 3, and here we have minus 1 x plus 3, this is equal to 0. So we have x plus 3, and here we have x minus 1 is equal to 0. So the turning points are given by x is equal to 0, x plus 3 is equal to 0, and x minus 1 is equal to 0. So we have x is equal to 0, then from here we have x is equal to minus 3, and from here we have x is equal to 1. So we have here three turning points, right? So let us now test these points for maxima and minima by using the second derivative test. So now let us first take x is equal to 0, and let us find out the value of the second derivative at x is equal to 0. So here we have 36 times 0 square, then we have 48 times 0 minus 36. So this term is 0, this is 0, so we have minus 36. Now this is negative, that is less than 0. Now the second derivative test says that if the second derivative is negative, that is less than 0, then z is maximum, right? And if the second derivative is greater than 0, that is positive, then z is minimum, right? So here the second derivative at x is equal to 0 is negative, that is less than 0. So we can conclude that this point, that is x is equal to 0, is a point of maxima, right? Okay, now let us take x is equal to minus 3. So the value of the second derivative at this point, that is minus 3, is given by taking x is equal to minus 3 here. So we have 36 minus 3 square, then we have 48 times minus 3 minus 36. So here if we multiply both these numbers, we'll get 324, and here we have minus 144, this is minus 36, and 324 and minus 144 is 180, and here we have 36, so this is 144. So this is plus 144, that is greater than 0, right? So this point, that is x is equal to 3, is a point of minima, because here the second derivative is greater than 0. Now let us take x is equal to 1, right? So the second derivative at this point is given by this expression. So taking x is equal to 1, we have 36 times 1 square, then we have 48 times 1 minus 36. So we have 36 plus 48 minus 36. So 36 and 36 get cancelled, we have 48. So this is plus 48, that is greater than 0. So again by second derivative test, the second derivative at x is equal to 1 is positive. So at this point x is equal to 1 is a point of minima, right? So here we have 3 points, 0, minus 3 and 1, and from second derivative test we have seen that x is equal to 0 is a point of maxima, because the second derivative is less than 0, and here the points x is equal to minus 3 and 1 are points of minima, because the second derivative at these points is positive, that is greater than 0. So now this function z is maximum at this point x is equal to 0. So therefore this function y is also maximum at this point x is equal to 0 by this rule, right? Okay, so now here we can find out the maximum value of y by taking x is equal to 0 in this expression. So y is equal to 3 times 0 raised to 4, then we have 8 times 0 raised to 3, then we have minus 8, 18 times 0 square plus 60 raised to 5, right? So here we have y is equal to 60 raised to 5, right? So this is the maximum value of y which occurs at x is equal to 0. So now this function z is minimum at x is equal to 1, right? So y is also minimum at x is equal to 1. So let us find out the minimum value of y by taking x is equal to 1 in this expression. So we have 3 times 1 raised to 4, then we have 8 times 1 cube minus 18 1 square, and here we have 16 raised to 5. So here we have 3, this is 8, this is minus 18 plus 60 raised to 5. So this is 11, 11 minus 18 is minus 7 plus 60 raised to 5. So we have 60 minus 7, that is 53. So 53 raised to 5 is the minimum value of y at this point x is equal to 1. Now z is also minimum at x is equal to minus 3, right? So y is also minimum at this point that is x is equal to minus 3. So the minimum value can be obtained by taking x is equal to minus 3 in this expression. So now we have y is equal to 3 times minus 3 raised to 4, then we have 18 times minus 3 raised to 3 minus 18 minus 3 square plus 60, and here the power is 5. So now y is equal to 3 times minus 3 raised to 4 is 81. Then we have 8 times minus 27. Then we have minus 18 times 9. Then we have 60 raised to 5. And here we have 3 times 1, 3, 3, 8, 24. And here we have minus 216, and here we have 162, and then we have 60 raised to 5. So now we can have 243 plus 60 is 3, 0 and 3, right? And here minus 216 minus 162 is 8, 7 and 3, and this is 5, right? So 303 minus 378 is minus 75 raised to 5. So this is minus 75 raised to 5, right? Because here minus 1 raised to 5 is minus 1. So the minimum value of y is given by minus 75 raised to 5, right? So whereas here we have seen that this function y is maximum at x is equal to 0, and this is the maximum value, that is 60 raised to 5, and the minimum value it occurs at 2 points, that is x is equal to 1 and x is equal to minus 3, and the minimum values are 53 raised to 5, and this is minimum, and here this is also minimum, right? So this is how, by making use of this concept, that is, if y is a function which is some power of other functions, say f of x, then y is maximum or minimum according as f of x is maximum or minimum. So this is an important application of the second derivative test. Hello viewers, in today's session we are going to discuss a very important and conceptual problem from a range of functions, and in this session we are going to find out the range of this inverse trigonometric function, that is f of x is equal to tan inverse 2x minus x square, right? So here we'll see how we can find out the range of this function by using some concepts, right? So here let us first see the concepts which are going to be used to find out the range of this function. So now let us first take y is equal to f of x, that is tan inverse 2x minus x square, right? Now see, whenever we have a function, say y is equal to f of x, and this x is known as the independent variable and y is known as the dependent variable, then for all values of valid values of x, we have a corresponding value of y, right? So this y constitutes the range of the function f of x, and all valid values of x are known as the domain of the function, right? So this is the first thing. And then from inverse trigonometric functions, we know that the range of the function, that is tan inverse, is given by minus pi by 2 to pi by 2, right? And here we have the open interval. So this is the second thing. Now the third thing is that the function tan inverse is an increasing function, because if we differentiate tan inverse x, then the derivative of tan inverse x is 1 over 1 plus x square, and 1 over 1 plus x square is greater than 0 for all values of x belonging to the set of real numbers, right? So this tan inverse x is an increasing function. So these are the two important concepts which are going to be used to find out the range of this function. So now let us take this tan inverse y to this side. We can have tan y is equal to 2x minus x square. Now see, this 2x minus x square is a quadratic polynomial, right? And here what we will do, we'll try to convert this quadratic polynomial into a perfect square. So taking minus sign common here, we can now write x square minus 2x. So we can now write x square minus 2x, now adding 1 and subtracting 1. So now this trinomial, that is x square minus 2x plus 1, is equal to x minus 1 square, that is a minus b square. So we have a square plus b square minus 2ab, that is minus 2x. So now we can write here this term as x minus 1 square minus 1. So now multiplying here these two terms by this negative sign, we have minus x minus 1 square plus 1, right? So what we have done here, we have expressed tan y as minus x minus 1 square plus 1, So now let us move from this step, that is x minus 1 square. Now see, x minus 1 square is always going to be greater than 0 or equal to 0. For x is equal to 1, the equality holds, and for other values of x, x minus 1 square is always greater than 0 or it is positive, because this is a square term, right? Okay, now what we will do, will multiply both sides by minus 1. So when we multiply both sides by minus 1, we have the reversed direction of the inequality. So we have minus x minus 1 square is less than or equal to 0. So when we multiply both sides of an inequality by a negative sign or negative number, then the direction of the inequality, it gets flipped, right? Okay, now here we have 1. So adding both sides 1, we have 1 minus x minus 1 square, and here we have 0 plus 1, that is 1. Now see, this expression is 1 minus x minus 1 square. So 1 minus x minus 1 square is equal to tan y. So we have tan y less than or equal to 1, right? So this is an important inequality in connection to finding out the range of this function. So we have tan of y is less than or equal to 1. Now let us take tan inverse of both sides. So we have tan inverse, and here we have tan of y, and here we have tan inverse of 1. So what we have done here, we have taken tangent inverse of both sides. But here see, the direction of the inequality doesn't change, because this tan inverse x is an increasing function, right? So the inequality remains, the direction of the inequality remains the same. So here tan inverse tan y is simply y, and here tan inverse 1 is pi by 4, because we know that tan pi by 4, that is tan 45 degrees, is equal to 1. So pi by 4 is equal to tan inverse 1. And here from inverse trigonometric functions, we know that tan inverse of tan theta is equal to theta. So here we have y. So y is less than or equal to pi by 4. So now y is equal to tan inverse 2x minus x square. So we can also write tan inverse 2x minus x square is less than or equal to pi by 4. Right? Now see, here we have just discussed that the principal value branch of tan inverse is minus pi by 2 to pi by 2. So here we have minus pi by 2, and here we have pi by 2, right? And both these points are not included. So here we have y less than or equal to pi by 4. Now here y is less than or equal to pi by 4. So let us locate y is equal to pi by 4, and pi by 4 lies between minus pi by 2 and pi by 2. So pi by 4, it lies somewhere here, and here pi by 4 is included, because here y is equal to pi by 4 and less than pi by 4. So now this inequality, that is y less than or equal to pi by 4, it suggests that we have to consider only this interval, right? See, the principal value branch of tan inverse is from minus pi by 2 to pi by 2, and here we have obtained this inequality, that is y is less than or equal to pi by 4. So we have located pi by 4 in between minus pi by 2 and pi by 2, and y less than or equal to pi by 4 suggests that we have to consider only this interval, that is our y. It belongs to the interval that is minus pi by 2 and here we have pi by 4 because here the equality sign holds, right? So y belongs to the interval which is open from left and closed from right. So y belongs to minus pi by 2 to pi by 4, and y is our function that is tan inverse 2x minus x square. So tan inverse 2x minus x square, it belongs to this interval that is from minus pi by 2 to pi by 4, and this is the range of this function tan inverse 2x minus x square. So viewers, this is how by making use of these concepts, that is principal value branch of tan inverse function, and then the increasing nature of the function tan inverse x, and some simple algebra, we can easily find out the range of these type of functions.